Hello everyone. Welcome to Subnetting a little bit. We will discuss more elements of IPv4 addresses. Here are the topics we will discuss. Introduction of the address map. A quick review of IPv4 addresses. The network and host portion. Classful addressing schemes. The total number of networks and the total number of addresses per network. Recall an IPv4 address has 4 octets. Each octet has 8 bits. This gives us a total of 32 bits. It has a network portion, denoted by the network bits, and a host portion, denoted by the host bits. The network portion identifies the group of devices in a network. The host portion identifies the individual devices in a network. We use what this series calls the address map. The address map uses uppercase and lowercase letters to identify the type of bits in an IPv4 address. Fundamentally, there are only 2 types of bits: network bits and host bits. In a classful addressing scheme, this series typically refers to the address map as the native address map. If the address has been subnetted, it loses its classful property, and this series refers to it as the subnet address map. However, sometimes we'll just use the term address map to refer to either variation. In the address map, each uppercase letter represents 1 octet, which equates to 8 bits. Lowercase letters represent 1 bit. More on the address map later in the series. For Class A addresses, the native address map will always be n.h.h.h. The first 8 bits are network bits. The remaining 24 bits are host bits. For Class B addresses, the native address map will always be n.h.h. The first 16 bits are network bits. The remaining 16 bits are host bits. For Class C addresses, the native address map will always be n.n.n.h. The first 24 bits are network bits. The remaining 8 bits are host bits. In summary, here we see the address class, the corresponding range of the first octet, the native address map, as well as the number of network bits and host bits. The following applies in a classful addressing scheme. First, we'll look at Class A addresses. The total number of networks possible in the Class A address space is 126, not 128. This is because addresses that have a 0 or 127 in the first octet are reserved. To determine the total number of addresses per network, use the formula 2 to the h, where h is the number of host bits in the address map. Since there are 24 host bits, set 2 to the h equal to 2 to the 24th. This equals 16,777,216. However, 2 of those addresses cannot be assigned to a device, the first and the last. In either case, this means every network can have over 16 million addresses. That is too large of a network and too difficult to manage. Plus, it violates security best practices. Subnetting allows us to subdivide a network into smaller, more manageable networks. Let's look at Class B addresses. To determine the total number of networks in the Class B address space, use formula 2 to the n, where n is the number of network bits in the address map. Since there are 16 network bits, set 2 to the n equal to 2 to the 16th power. This equals 65,536. For the total number of addresses in each Class B network, use formula 2 to the h, where h is the number of host bits in the address map. Since there are 16 host bits, set 2 to the h equal to 2 to the 16th. This equals 65,536. This means we can have a total of 65,536 Class B networks. And each network can have a total of 65,536 addresses. However, as previously mentioned, there are 2 addresses in every network that cannot be used. Finally, let's consider Class C addresses. To determine the total number of networks in the Class C address space, use formula 2 to the n, where n is the number of network bits in the address map. Since there are 24 network bits, set 2 to the n equal to 2 to the 24th power. This equals 16,777,216. For the total number of addresses in each Class C network, use formula 2 to the h, where h is the number of host bits in the address map. Since there are 8 host bits, set 2 to the h equal to 2 to the 8th. This equals 256. This means we can have a total of 16,777,216 Class C networks. And each network can have a total of 256 addresses. However, 2 of those addresses cannot be assigned to a device. If you are wondering why 2 addresses in every network cannot be assigned, be sure to watch the next video in the series. This table summarizes the total number of networks and the total number of addresses per network when using a classful scheme. This table includes the formulas. That's it for now. Thanks for watching. And remember, nothing worthwhile comes easy. So go forth and subnet a little bit.